We're going to Jupiter with the spacecraft. It's going into the worst radiation field in the solar system. And we think we're ready, but no one's ever done this before. Well, the most important thing you should know about Juno is we are trying to understand how did Jupiter form in order to understand how did the solar system form? Where do we come from? If I want to know, how do I get to making the Earth? I need to know, what is Jupiter made out of? Jupiter's more than twice the mass of all the other planets combined.
Juno will orbit closer to the planet than any other spacecraft, and it will go to higher latitudes. And what we find there will be a first.
From an engineering perspective, the thing that's most interesting to me is how much we can learn about the inside of the planet when everything we measure is outside. I'm really interested in understanding what the interior is going to tell us, what the structure is. Is there a core or not?
All of those questions, big questions about how do planets form, are the questions that Juno's trying to answer.
We are the very first solar power mission to go this far into the solar system. And one of the reasons why that works is because we are orbiting Jupiter in a way that the planet never blocks the spacecraft's view to the sun. Associated with that, our solar arrays are enormous.
When you look at our spacecraft, the first thing that jumps out at you is just the size of it. Our solar arrays are immense. Our spacecraft is roughly the size of an NBA basketball court.
Over the last 20 years or so, solar efficiency has gotten about 50% better. It really has allowed us to kind of cross a threshold where it was feasible to do solar at Jupiter.
There's so many different features in the mission that just tie together. It's like a painting. It's like a work of art. It's a beautiful, elegant mission, the way it was constructed and the way it was put together. It's going to give us some beautiful, elegant science.
Literally, the planets have to align. You have to launch when Earth and Jupiter are in the right place. Because if you miss that launch date, we'd have had to wait well over a year before we could do it. The next critical event we had was opening the solar panels. If you don't get those solar panels open within the first few hours, you don't have a mission, you don't have a spacecraft, you're dead. We weren't even able to test that properly on the ground. We test opening the solar panels, but that's in Earth's gravity.
Jupiter has the scariest radiation environment of any planet in the solar system. There's a huge population of energetic electrons. They're moving at almost the speed of light. They basically are like a spray of machine gun fire hitting a spacecraft.
The amount of radiation that would kill a person is about 1,000 rad. At Jupiter, we see approximately 20 million rad over the lifetime of our mission. It's kind of like the epic tale, man versus beast, David versus Goliath. Who's going to win? I don't know.